All right, so in 7.5 we continue with solving trig equations, but we get to some more involved problems that require a little bit more than just kind of looking at the unit circle. So maybe take a second to pause and write this down, this little kind of flow chart, and I'll talk through it a little bit. But like basically, the main goal here is, can you isolate a trig function? Can you get it to say sine equals a number or tangent equals a number, whatever? If you can, then you're golden. Then it's just a unit circle problem. You don't need formulas. You don't need to double angle or square root. You don't need any of that. Okay. The only thing we're going to add this type of problem here is if there's a horizontal transformation, meaning if it's sine of 2 theta or cosine of 3 theta or theta over 2, whatever. If there's something inside with the theta, okay, then we have this kind of need to do plus 2 pi k or plus pi k, whatever the period is, because the horizontal transformation is going to change how many solutions there are compared to what we were expecting. Right? So if it's a 2 theta, that means it's been compressed. That means we're going to have more solutions than we would have. So in order to find them, we do this 2 pi k thing. You'll see an example or two with that. If we can't isolate a trig function, then our job is going to be to try to simplify in a way using a formula, like a double angle formula or a sum and difference formula. Or maybe we have a trig identity, like sine squared plus cosine squared equals 1 or something related to that. You can also factor. We did a little bit of that last section also. Squaring both sides is another strategy that works. Okay, so let's try some problems here. First one here, we've got 1 plus sine of theta equals 2 cosine squared theta. We're going to solve it for all theta. Notice on here, we're not going to be able to isolate, and just get it to say sine theta equals a number or cosine theta equals a number. So here, I need to use some formulas or identities or something to try to simplify this. And one of the things I notice is that I've got cosine squared, which I could turn into sine. Here's sine. I could turn cosine squared into sine using the identity, the Pythagorean identity. So we're going to do that. We're going to go 1 plus sine theta equals 2, and then cosine squared equals 1 minus sine squared. So 1 minus sine squared theta. And then I can distribute. And now we've turned it into one of those quadratic ones we were working on the other day. So I'm going to get it equal to 0, move the sine squared, 2 sine squared to the right, 2 sine squared theta plus sine theta, and subtract 2, give me minus 1 on the left side equals 0. So now we can go ahead and factor that. Let's see, I have sine theta and 2 sine theta. And then I definitely have 1 and 1. So to get positive, I'm going to want the plus here, a minus there. Okay. And then we set each of these factors equal to 0, which will give me sine theta equals -1. And sine theta, add 1, divide by 2, equals 1/2. And now I can just look at unit circle here. Okay, so sine is -1 at that angle there at 3 pi over 2. Sine is 1/2 there and there, the pi over 6 and 5 pi over 6. But we want all theta, so we're going to say plus 2 pi k. So let's see. We have theta equals 3 pi over 2 plus 2 pi k. And then we have also pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. And there's our answers. Okay, for number 2, we've got a similar situation. I can't isolate. But here, I've got sine 2 theta minus cosine theta equals 0. I look at sine 2 theta and I'm thinking, well, maybe I can use a double angle formula. sine 2 theta, sine, cosine, cosine, sine. It's the formula that's 2 sine theta cosine theta minus cosine theta equals 0. Okay, and in this time, my factoring is a GCF. I can factor out that cosine theta. So cos theta times 2 sine theta minus 1 equals 0. So I get cos theta equals 0 and sine theta equals 1/2. That's familiar. And here, cosine theta equals 0 happens twice. And notice that's happening pi apart. So I can be a little more efficient with this answer and say that this is pi over 2 plus pi k. Here, it's the same 2 as before the last problem. So then I'll also have theta equals pi over 6 plus 2 pi k, and theta equals 5 pi over 6 plus 2 pi k. Now in this third problem, cosine theta plus 1 equals sine theta. Still can't isolate a trig function, but I also don't really have any identities or formulas that involve just sine or just cosine. It's always squared or 2 theta or something. So here, this is a situation where, like, if you're kind of stuck, but you've got 2 trig functions, one on each side, an idea is to square both sides. So hint, square both sides. Because we do have formulas and things we can do with trig functions that are squared. So let's see what happens if we square both sides. I get cosine squared theta plus 2 cos theta plus 1 equals sine squared theta. Okay. Now, by squaring both sides, we've potentially introduced some extraneous solutions, so we have to be thoughtful about that. Okay. And now, okay, I can use the trig identity with sine squared. This is all cosine over here. I can't change the plane cosine, so I'm going to want to use the trig identity with sine squared. So I'm going to have you pause the video, try to finish this one up, and see where you end up, and I'll put the answers up in a second. Okay, so we're not quite done yet, but let's see if you can get to here. Notice we are from 0 to 2 pi now, so I've only got these 3. I'm not doing plus pi k. But let's check to make sure these work in the original. Because we squared both sides, we need to check for extraneous solutions. So if I plug in pi over 2, I get 0 plus 1 equals 1. So that's okay. Like 1 equals 1. And it's before I squared it. Then pi, I have cosine of pi is negative 1, plus 1 is 0. Sine of pi is negative 1. Or sorry, sine of pi is 0. So we have 0 equals 0, so we're good there. What about 3 pi over 2? Cosine of 3 pi over 2 is 0, so I get 1 equals sine of 3 pi over 2 is negative 1. Oh, so 3 pi over 2 is extraneous. We're going to cross it off. So my only 2 solutions there are that. All right, now in number 4 here, we are solving this over 0 to 2 pi. We got 2 sine of 3 theta minus 1 equals 0. Here I'm going to try to isolate, I can isolate sine, right? So I can turn this problem into sine of 3 theta equals 1/2, right? But notice the difference here. This one has a horizontal compression, 3 theta. It's not just theta, it's 3 theta. We have to do this problem a little differently because of that. That's going to compress the trig of sine 3 theta, compresses it, so we're going to have more solutions than we typically would. So what I like to do here is still figure out, where is sine equal to 1/2, and that's our pi over 6 and 5 pi over 6. But instead of writing theta equals that, we got to write 3 theta equals pi over 6, and then because I gotta figure out how many answers there are gonna be when I get rid of that theta, 3 theta. I gotta do plus the period pi k, so 2 pi k. I can also write the 3 theta will equal 5 pi over 6 plus 2 pi k. And I know we're not solving over all theta. That's usually when we use 2 pi k. But because of this 3 theta, we need to do that. And so here's what's going to happen. We're going to divide by 3. Okay, and that's going to give me theta equals pi over 18 plus, and then what I like to do is get a common denominator here. So it's 2 pi k over 3, but I'm going to get it over 18. So what would that be? 12 pi k over 18. And so now what I'm doing is I'm going to add 12 pi over 18 over and over and over again until I get bigger than 2 pi. And so I know one of my answers here is pi over 18. And then if I add another 12 pi is over 18, I'm going to get to 13 pi over 18. If I add another 12, I'd be at 25 pi over 18. And that's still okay. That's still less than 2 pi. Can I add any more? Let's see. 37 pi over 18. Well, 2 pi would be 36 pi over 18. So we're done with this bunch. And I'm going to do the same thing over here. Divide by 3, divide by 3, divide by 3. I got theta equals 5 pi over 18 plus 12 pi over 18k. And then that's going to give me more answers for my list here. So I got 5 pi over 18, add 12, 17 pi over 18, add 12, 29 pi over 18, add 12, oh, that'd be 41, that'd be too big. So there are my 6 answers. All right, we got time for one more here. 3 sine 2 theta equals root 3 cosine 2 theta. Sort of an interesting one here because what we can do is actually divide to turn this into tangent. Right? There's no adding or subtracting, so we can use division now, and we're going to turn this into tangent. So if I divide both sides by cosine 2 theta, I'm also divided by this 3 to get that over here. Then I'm going to have tangent of 2 theta equals root 3 over 3. All right, well, where does tangent equal root 3 over 3? And again, this is going to be over 0 to 2 pi. Tangent equals root 3 over 3 here and here, positive. Okay, so that means we're going to say 2 theta equals pi over 6 plus, and actually what's nice is that's happening, like these two answers are pi apart from each other, so I don't need to do this twice. I can just do plus pi k. So then I'll divide by 2. I get theta equals pi over 12 plus 6 pi over 12. There's that common denominator k. And now I can list off as many answers as I can between 0 and 2 pi. So we'll say pi over 12, add 6. 7 pi over 12, add 6. 13 pi over 12. Okay, add 6. 19 pi over 12. Add 6 would give me 25 pi over 12. Too big. Gotta stop. There we go. All right, thanks for watching.